DeepSeek Flash 0731 came out and the internet done lost its damn mind. Maybe not Frontier, some things claiming Opus level, but the idea that you could actually run this on a home computer setup with $500,000 worth of GPUs, excellent. What if you just have a laptop? Well, I've got a laptop and I've been tracking the DwarfStar project. DwarfStar DS4 is from the creator of Redis, and he's been working for a while on getting Flash and some other models really squeezed down onto devices that consumers can buy with Apple and NVIDIA and AMD versions of things with different targets for GLM for a much bigger model. Laguna S, I've been playing with Laguna XS. But with the arrival of DeepSeek for Flash and this MXFP4 thing that really just got people really excited, he merged it to main, continuing to work on it. I'm going to show you what it looks like. But first, let's talk about why you would care about DwarfStar. It's an attempt to try and get some of these bigger models to be usable on regular devices. Now, in my case, I've got a M5 Max laptop M5, with 128 gigs of RAM. So that's big, it's expensive, but it is within reach of people and you can take it on a plane. Why is DwarfStar so cool? It's doing some low-level backends that really tap into the lower-level machinery for inference. And then you can get something heavily quantized without losing a lot of quality because of the way he manages the experts. You can even do things like get them to stream from disk so that the experts and layers and things that you don't need sit there on disk. The things you do need eventually get in memory on your GPU. And you could get like Flash on 50 gigs of RAM or something like that. What does it look like? Let's go take a look. I'm running DS4 DwarfStar on my MacBook Pro, and I'm running it through his native agent, DS4-agent, which is itself pretty interesting. Instead of talking to an OpenAI compatible HTTP server and getting into all this crap about HTTP latency and parsing tool calls and stuff, he's talking directly to the local KV cache, and it brings in a whole bunch of cool features. I'm in the middle of a real project in a real directory with lots of work that's been going on, spec-driven development for building a harness for the Pi coding agent. I'm in the middle of phase 5, cycle 5, and I've got a spec written for it. Beginning of a spec. Am I ready to go and do some real development? Sure. Let's get started on cycle 5. Now, DS4 agent doesn't support skills and a whole bunch of other things. So it's at a little bit of a disadvantage to go with some of its advantages. How fast is it? Let's go. All right. You see some tokens happening down here, some pre-fill and thinking and all that stuff. Obviously, the thinking part's faster than I can read. So it's pretty fast. Here we go on some decode and stuff. So, 34 for prefill maybe, if I'm reading this correctly, and 200 plus for decode. All right, so it's warming itself up a little bit. It's getting its little KV cache warmed up. This is a persistent KV cache. So once it's done some work and you fire up another agent, another process, that prefill part will be kind of pre-computed a little bit. All right, it's going through looking at my incredible list of spec-driven development documents, trying to figure out its little universe. So it's catching up to what my Claude agent had already been able to do. All right, now it's taking a look at what we're trying to do in this feature cycle, cycle 5. And we want the Pi agent to be able to handle some exception conditions. When I do like n equal 32 to do a whole bunch of runs at once, it starts exposing some conditions where it gets into a loop against a small language model and things like that. So we're basically working on a Pi coding agent extension. All right, so it's going through, doing some thinking on some things, and it's taking a look at the source code of Pi, which I have locally, which has an extension about subagents to understand what these subagents are supposed to be doing. Let's see. So it couldn't find an installed version of Pi package, at least the newest version, because I'm got a local checkout that's on a branch. So you kind of get an idea of some of the speed of the Flash 0731 variant that just came out and is blowing people's minds. From a quality perspective, is it to the level of Opus? I don't have enough experience quite yet to say whether it is or isn't. I do know that it's not even close to Fable. I take these results and I send them to Fable, and Fable finds a whole bunch of problems with it. All right, doing a little bit more research, getting along with the things that it needs to be doing. You can see some of the performance numbers at the bottom. And it's doing some real thinking. You know, this is a hard project that I'm doing. And I've got a whole bunch of basis, so to speak, already in different work trees and markdown documents and code. And it's trying to digest the source code of the Pi coding agent. And the problems that it's trying to solve are not really routine problems that you can expect to be in a training data set for any model on Earth. Like I said, I don't have a way to help it with skills. I could tinker with the system prompt to kind of give it some guardrails a little bit if I needed to. But as this DwarfStar KB cache starts to warm up, then I'll be tackling some of the pre-fill issues that traditionally are a problem for the MacBook, for the Apple Silicon speeds compared to some of the speeds with the NVIDIA side. That said, the M5 does tackle that directly. I've got metrics to prove the 6x prefill really is a thing on this architecture. All right, it found the previous telemetry that was really causing me a problem and saw that it was a diagnostic issue. That in a way, one of the things that happens in this project is something isn't really a problem, but the diagnostics claim that it is a problem. So you need a model that can challenge its assumptions, look behind the scene, and find the actual underlying data instead of the analysis that went with that data. Here it is, it's starting to write the spec for cycle 5, and then give me a chance to review it. So it's still doing more to try and write the spec and the implementation plan for it. It's done all the research it needs. And just as a little bit of a background, I would expect if I restarted this from scratch with a brand new DS4 agent process, this would have been a good bit faster because the KB cache would have a good bit of this stuff in it. It'd still have to go out and discover all those kinds of things, but all right. This is pretty cool to see some of the reasoning that's happening with this Flash model. These things that it's figuring out are real. I can promise you these are fairly complicated sets of assumptions and challenges of the assumptions that it's following the trail on and finding out how we got to this point. A spec-driven development project that's in phase 5, phase 1 might have like 18 cycles in it. We're trying to build an orchestrator tool subagent thing for Pi to help small language models, local like 12 billion parameters, succeed. And this orchestrator is just a really finicky thing to get right. It's a finicky thing to orchestrate the orchestrator, so to speak, by having a harness that can run Pi maybe once, maybe 4 times, maybe 100 times, collect evidence, and just be really resilient to all the things that can go wrong. All right, I'll go ahead and stop this here. You get a feel for the thinking that it can do, the tokens per second that it can do on prefill, the tokens per second that it can do on decode. And just a little bit of an experience of using it in DS4, DwarfStar 4's agent. Maybe I'll do a video later about running DS4 server, which is the OpenAI compatible server. Then I can hook it up to Pi or to OpenCode, use all the skills that I have, might speed things up a little bit.